We are in section 14.2, Arithmetic Sequences and Series. And here are the exercises for this section, the ones that are highlighted. And we're going to do ones very similar to the ones you're looking at. So let's get started on this one. Now, coming into this section, we talked about sequences and series in previous section. We mentioned a sequence is a function whose domain is the set of natural numbers. And the series is when we find a sum of possibly finite number of terms in a sequence. In that case, we have a finite series, and the series could be finite or infinite. If you're adding all the terms of the series to infinity, then the series is called infinite series. But in previous section, we looked at sequences and series in general. In this section, we're going to look at a very specific kind of a sequence, and that's called arithmetic sequence. So let's actually begin with kind of set up how this thing is going to turn out and what is an arithmetic sequence. So in my example, I'm just going to make up a sequence here. Let's say I have sequence 7, 11, 15, 19, 23, and so on. So suppose this is an infinite sequence. Now, when I made this up, I made it to where, if you notice, the difference between these consecutive terms is the same, right? The difference 4, 4, 4, and 4. In other words, if I go from 7 to 11, I'm going to add 4. 11 to 15, you add 4. So each time I add 4 to the previous term to get the next term, right? So this is what the signature of an arithmetic sequence is for an arithmetic sequence. So let me write down the observations that we have made here. So if I do 11 minus 7, I get 4. I do 15 minus 11, 4. Next term, minus the one before, 4. 23 minus 19, 4. So notice how these are the same, right? We call these common differences. Okay, so that's what those are, common differences. Another way to think of this is that if I do 7 plus 4, I get 11. Add 4 to 11, you get the next term. 15 plus 4, you get 19, and so on. So this is how you get your next term and the next term. So that common difference is added to the prior term to get the next term. Okay. So the keyword here or words are common difference. So in general, now I can write it like this. In general, if I have A1, A2, A3, and so on, all the way up to A sub n, the general term, and so forth. So if I do A2 minus A1, that's how I get that common difference. Also, if you do A3 minus A2, that should be the same. And if you do, let's see, the next one will be, if you do A4 minus A3 equals common difference, and so on and so forth. And all the way up to this term. So the nth term minus the one before it would be n minus 1 would equal to d. Okay, so this is true about all arithmetic sequences. The difference between successive numbers must be the same. So this is how your book's gonna describe it also. So the definition of an arithmetic sequence is such that there is a number d here. Remember, d in this definition is the common difference. So that in order to get the next term, that's a sub n plus 1 they have, to get the next term from the nth term, you add common difference to the nth term plus a common difference. So that's the rationale behind it. Now this form of definition of an arithmetic sequence, by the way, is what we call a recursive definition. This definition here is called a recursive definition of an arithmetic sequence. Recursive because one term is stated in terms of the other. Okay, and again, in this case, the next term, n plus first term, is defined as the term prior to that would be the nth term plus a common difference. Okay. Now, we don't want to work with this form, the recursive form. So let's actually look at an alternative to the nth term. Okay, we want to be able to write a formula for this function. Previous section, I said there's no way we don't have a formula for the ones we saw. We had to look for a pattern to decide on a sub n, the function, the general term. In this section, because the way these sequences are structured, we can actually derive a formula for the nth term, and this is how that derivation goes. Okay, so we begin by looking at our first term. So this is our first term. Now remember, to get to the second term, you add the common difference to the first term. To get to the third term, you add the common difference to the second term, and so on and so forth. So if we continue on doing this, then we actually have a formula for the nth term in the highlighted formula, the one that you're looking at here. This is the formula. And what happens is right up here, these are all recursive definition. Now remember, A2 itself is A1 plus D here, so they substitute A1 plus D for A2 in here. Do the arithmetic, you have 2D's, A1 plus 2D. They do the same thing with the next one. For A3, they put A2 plus D in here. Now, instead of A2 plus D, let's see A3. A3 is A1 plus 2D, so they substitute for A3 here, this expression. A1 plus 2D plus D, and that's A1 plus 3D. And what they're looking at here now is the following, what they're trying to show in this expression. They're saying that, look at the subscript is 4, the number in front of D is 3, which is 1 less than that. So if we extend the pattern that we see, then it makes sense that for the nth term, so for example, if I look at the 10th term, it's going to be A1 plus 9D, right? If we extend the pattern that we see. If I look at the 50th term, it's going to be A1 plus 49D. That's what this expression is saying here and in here. Okay. Now, we can generalize, and actually the formula below is what we want to know. This is the formula for the nth term of an arithmetic sequence right in here. Okay. Now, to use this formula, we need to know the first term, right? We need to know the first term and the common difference. N is going to be general, so we're not going to have a number for n if you want to have the general function. And then there's also a formula for the nth partial sum. We are interested in two things in this section. The formula for the nth term, for this one right in here, which we have, and a formula for the nth partial sum. This will give us a finite sum of however many terms in that arithmetic series. Now there are two formulas for this. The one that you see on the left, this one, in order to use this one, you need to know right in here, you need to know your first term, and you need to know the nth, which is the last term. So if you know first and last, and we'll see an example later where in fact we do, and I can use this formula. If we don't know the last term, we just are given, let's say, first term and a common difference, then this other version I have right in here, this comes in very handy. And you can derive this formula, it's not difficult. Right in here for the nth term, I went ahead and put this expression for the nth term. If you plug that into here, you get what's in the brackets, what I have to the right, you get this. Okay. So you have two options for the nth partial sum. Let's take a look at an example. Now, in this example, number 8, we are given an arithmetic sequence, and the questions ask us to find the first term and the common difference. Okay, so, well, we can find the common difference. Remember, the common difference is when you subtract first term from second term, or second from third, or third from fourth, and so on. So I usually do second minus first term. So that means this is going to be -5 minus -8, and that makes it, what, 3? That's our common difference. And what about the first term? The first term is actually right in here. And that would be our first term, right? That's what this is. That's our first term. Okay. And so I'm going to just write that. Our first term is -8. So those are it. Those are the answers to this exercise. Pretty simple, I hope. Let's look at the next one. In this next one, we want to find the 23rd term now in that sequence. Notice the sequence is arithmetic because the common difference here is 6, right? See, the distance between these terms is fixed. That's common difference, D, is 6. You can do 16 minus 10, second minus first to get that. So what else do I need? I need to know the first term, right? So what is our first term? Our first term is 10. And then to find any term, that's what A sub n does, finds any term. I'm just going to use the formula that we have up here. See this formula? This one right up here. A1 plus n minus 1 times D. That's going to be A1 plus n minus 1 times common difference. Now A1 is 10 plus n. N is going to be general, whatever n is. And D is 6. So this is going to make this 10 plus 6n minus 6, right? And let's see. Oh, that's actually the general form. That's fine. I'm finding the nth term. That gives me 4 plus 6n. This will give me any term. See, this is for any term. Now, the question is asking for the 23rd term, right, in this sequence. So I'm just going to plug in 23 for n. So A sub 23, that's when you put 23 in for n. That's 4 plus 6 times n is 23. See, that's what A sub n is good for. And 6 times 23 plus 4, that's going to be 120, 130, 142. Right? Hopefully I did that without a calculator. And that's what I got. Okay? So that's how you find any term in an arithmetic sequence. Again, this formula only works for arithmetic. So if it's something other than that, this isn't going to work. Now, let's take a look at the next part. Oh, for you're doing exercise number 29, and I didn't find one quite like it where the numbers work out nicely, so I made up my own. So let's take a look at this one, which is like your number 29. In this exercise, let's say we're given two terms somewhere in the middle of the sequence. See, I'm given the 10th term. I'm given the 16th term. I'm not given the first term. And the question asks us to find the first term and the common difference. Okay, so here's how you can work this one. If you look at A10, A11, ... and A15 and A16, right? I go from 10 to 16 because those are the two terms that are given. Now, if we look at how many differences there are between these, okay, ... Well, there are 7 terms in this sequence, right? From 10 to 16, including the 10th term, there are 7 terms. These 7 terms partition the distance from A sub 10 to A sub 16 into 6 common differences. There are 6 common differences. Okay, which is 1 less than the number of terms in general. So in other words, here's what I'm thinking. If a sub 10 is 50, okay, this distance from a sub 10 to a sub 16, and that's 68. This distance, which is 68 minus 50, 18 units, that distance holds 6 common differences. You see this one there in the middle, 1 2 1 2. So that's what that is. So I got a difference. See, there are 6 common differences there. So that 18 unit distance is made up of 6 differences. So that means from this d is 3. Well, if d is 3, then I have a formula for the nth term, correct? The formula for the nth term is a1 plus n minus 1 times d, right? So if I do this formula for the 10th term, because I'm given, see, the 10th term is given, so is the 16th. You can use the 16th term also, but I'm using the 10th term, okay? So if I use the 10th term in here, this is going to become plus, remember n is 10 now, right? Because that's what this subscript was, right? I'm doing this for the 10th term. 10 minus 1, and the common difference we found it to be 3. Now the value of the 10th term is given to be 50. That's a1 plus 9 times 3, which is 27. 50 minus 27 is a1, so a1 must be 23, right? And there you go. So we have the answer to the question. The question says find a1 and d, and we found both of them. Here's d and here's a1. Okay, so there you go. If you want, again, you can use a sub 16 to do that. Maybe I do that. Let's see. A sub 16. For a sub 16, this is going to be a1 plus now 16 minus 1. See, whatever n is, that's what this number is in red. So 16 minus 1 times 3. The 16th term was, what, 68? And a1, well, we want to find a1. Remember, we're doing it another way to find a1. That's 15 times 3. So if you do 68, 15 times 3 is 45. And 68 minus 45 is 23. So there you go. You see, those are the same. So either term would work. And we have the answer to the question. So you should be able to do exercise number 29 now. Okay, now let's take a look at this one, number 36. Okay, good. For number 36, question reads, find the sum of the first 400 natural numbers. Okay, now if we actually list the first 400 natural numbers, these are 1 plus 2 plus 3 plus ... plus 400, right? Aren't those the first 400 natural numbers? So from this, we get a1 is 1. And if you look at the distances, you see these all have the same distance, 1 unit apart. So d, the common difference, is 1 here. In fact, the series is an arithmetic series, so we can do the formula for in section 14.2 now in this exercise. And we are given the 400th term is 400, right? Because these are in order. And let me put d is equal to 1. We decipher to that. Okay, now let me use this formula. S sub n is n over 2, a1 plus an. And that makes it. Now, we want to find the sum of the first 400 terms, right? So it's going to be s sub 400, and that's going to be 400, that's n, right? 400 divided by 2, first term is 1, and the 400th term is 400, coincidental. That's 200 times 401, and that total turns out to be, I believe, 80,200. So there you go. we are done with that one. Now, we can actually do this in another way. Okay, let's do it another way. This way, I'm going to use a different formula. I'm going to use the alternative formula we have. S sub n is n over 2 times 2a1 plus n minus 1 times common difference. Now remember, n is 400, so I'm plugging in 400 over 2. First term is 1, 2 times 1 plus 400 minus 1. Common difference happens to be 1 also. That's going to be 200 times 2 plus 400 minus 1 is 399. And within bracket, I have, what, 401? 2 plus 399 is 401, which is exactly what the expression next to it is on the left. Right? That's what that is. So we reach the same step. Either way, we get the same answer. So the sum of the first 400 natural numbers is 80,200. The key was to write this out as we did and recognize that this series here, this is an arithmetic series. Arithmetic series. Once it's arithmetic, then we have the green light to use the formula for the nth partial sum. Okay, so we're done with that one. And let's take a look at our last exercise. In this last exercise, number 42. Here we are given a1, the first term is 9, the common difference is -3. We were told the series is arithmetic, and they want us to find s sub 32. Remember, s stands for partial sum. So we want to find the partial sum, the 32nd partial sum. Okay, so for this one, s sub n again, our formula was n over 2 times 2a1 plus n minus 1, common difference. Okay, now n is 32 here, right? So I'm going to go 32 divided by 2. We're given a1 is 9. That's 2 times 9 plus n is 32 minus 1, common difference, -3. See, everything is given here. So all you got to do is make sure you just use the right formula. 32 halves, that's 16. 2 times 9 makes 18 minus 32 minus 1 is 31 times -3 makes -93. 18 minus 93 is -75, and that product will equal -1,200. So there you go. That's the answer to this exercise. Okay, so we're done with this section. Again, just to recap, we had a couple of important information here about arithmetic sequences and series. The formulas that you see here are the formulas we need. We need these formulas again. These are important. Let me just go over them. Nth term and the nth partial sum. These two formulas are the formulas, the takeaway from this section. Okay. And with that, I believe we are done with this section. So if something isn't clear, please rewind the video and watch it again, and hopefully everything will be clear after that. And we're done with this video.